Okay, welcome to part 3 of lesson 1.2 of Math 0314. Okay, so I'm going to start this section, this last part, with a review of the previous question. After watching the video for myself, I think I can make it a little clearer. My intent here is not to redo the chart, but just to try to make the idea of the chart and why we made the distances equal more intuitive, right? So what we have Mr. Anderson. Here's Mr. Anderson. Mr. A. That's me. And here we have, what am I running towards? Math problems. Here we have, we'll call it MP for math problems. All right. So the idea here is whether I'm running towards or away, this distance never changes, right? So whether you go to your front door from your bed or from your bed to the front door, either way, it's always the same distance, right? Usually I'd say if you go from school to home or home to school, that distance would be the same, but school's at home now. So in any case, that's the case there. So that's why we ended up saying the distances were equal, because they're the same distance. The other thing I want to stress, I think is far more intuitive. I just said distance equals rate times time, but you know this because if you're in your car and you're going at 50 miles per hour for 2 hours, right? You know you've covered a distance of 100 miles. Right, and that's why distance equals rate times time. If we look at even the phrase miles per hour means miles over hours times 2 hours. Well, what ends up happening is our units end up canceling out. So we're just left with miles, and that's why the final result becomes miles. So hopefully if you are still struggling, that makes your life a little easier. So this was the question that we were looking at last time, so take a look at it. If you had done so already, try to solve it, pause the video, and in a sec we will discuss it together. Okay, so hopefully you had a go at it. This one's a little tricky. Jody drove 15 miles per hour slower on a trip to her math party. So if she regularly goes, and let's say her rate is R, then today she was 15 miles per hour slower. So today she was R minus 15. If her trip usually takes 3 hours, so that was the first part was 15 miles per hour. Now it says usually takes 3 hours, but today it took 6. So usually it's 3, but today it takes 6. What is her normal driving speed? So we're solving for R. So again, she's going to the same place, so just like here we were talking about from one destination to the other or back, in this case we're going to the same destinations both times, so the distance is still going to be the same. So the trick here is to realize some sort of similarity, right? And once you do, it's the same thing, so you multiply going down, so 6 times R minus 15 equals 3R. And we just solve. So distribute the 6. So 6R minus 15 times 6. Well, what? 60 plus 30 is 90. Equals 3R. Subtract 6R from both sides. So negative 90 equals negative 3R. And finish it off by dividing negative 3, and R is 30. So there you have it. By the way, another thing you want to make sure, it says what is her normal driving speed, and that is this value here, so that is what R is, because the question could have said what is her driving speed today, which means I would have to subtract 15, right? And I didn't talk about that in this particular question, but it is asking what is his speed running back, which was the value that I solved for. So get in the habit of also rereading the question. As you can see, even I have to get into the habit of rereading sometimes. Sometimes you just want to quickly run through a problem instead of looking at really what it's saying. So hopefully these make sense. They take some practice. You may want to rewatch some of these videos. It's a lot of information to digest at once, but hopefully this helps you out, and I'll see you in the next video.